In this lesson, we're going to talk about some key features of quadratics. A solar oven can cook food using the power of the sun. They are built using reflective material shaped as a parabola to reflect the sun's rays. So here's a solar oven. There's practical kind of application of quadratics. The graph shown below here models the shape of a solar oven. So let's talk about some of the terminology here. The vertex. The vertex, this is a really important word. You know it already in terms of triangles, a vertex being a corner. The vertex is the maximum or minimum. So the vertex, you think of it also as the corner or the turning point here. So where does this kind of have the most curved area? This right here where the mouse is pointing right there. I'll highlight that. That's the vertex. That point there, the vertex of a parabola. So in this case it's the lowest, it's the minimum. The parabola comes down, then kind of turns and goes back up here. It's a turning point. So this is the vertex of the parabola. When your parabola is in this shape, it would be the lowest point. But if you had a parabola that was shaped like upside down version of that, like this, then the vertex would be here. The vertex would be at the top, or it would be a maximum. The vertex of the parabola shown is, so what's the coordinate of the parabola shown? The vertex is a coordinate, it's not just a number. Let me roll it up a bit more here. So what is the coordinate right here of that point? So we state the x value first. This is my x value is a 5, and then the y value is a 1. So the coordinate of the vertex is 5, 1. Always write the vertex as a coordinate, always. There's two parts to it. The axis of symmetry. The axis of symmetry is an equation of the vertical line. So it's important that it's an equation. It's not a coordinate. This one, the vertex was a coordinate. This one's an equation of a vertical line that passes through the vertex. Your answer is always in the form, and this is really helpful to remember, your axis of symmetry. It's, even the word axis has an x in it, and here's an x. The axis of symmetry is always x equals some number. So what is that number? So let's look at the parabola below. Let me just erase this part here. The axis of symmetry is a line. I'm going to draw a line, a vertical line right through, it's usually a dotted line, right through the vertex. So I've got a little bit of a mess here because my ruler, the tablet doesn't always see my ruler properly, and it's hard to put a ruler on my tablet. Anyway, so this dotted line that I just drew is the axis of symmetry, and it's a line. So it has an equation. And all you have to do to figure out the equation is you look at where it crosses the x-axis. In this case, it's a 5. Or you just look at the first number of your vertex, and that will be your equation x. Don't forget the x equals 5. That's the equation of my axis of symmetry. So my axis of symmetry, it's called symmetry because I could take this line, along this line here, and I could fold my parabola in half. If I folded this, say this is on a piece of paper, and I folded my paper in half right here, this black curved piece would line up with this black curved piece. So that's the symmetry. It's symmetric here when I fold it here. Nowhere else. If I folded it along 8, it wouldn't work. The axis of symmetry goes through the x value of your vertex. So it has to pass through the vertex. That's your axis of symmetry. The next piece we're going to talk about is the y-intercept. You already know what a y-intercept is. The y-intercept is the coordinate where the graph intersects the y-axis. So our y-intercept is right here. There's our y-intercept. So the coordinate, the y-intercept, we're going to write it as a coordinate. The y-intercept is, so the x value is always a 0 on the y-intercept, and then 3 is the y value. The maximum or minimum, this is the y-coordinate of the vertex. This is kind of I always find this a confusing one because it's a maximum or a minimum. You have to first figure out which one is it. When I look at this parabola here, I can see that my vertex is the minimum point. My parabola is not going to go any higher than this. Now, this parabola is actually modeling this solar oven, but if it weren't, it would have arrows here and here. The parabola would keep going higher and higher. It would not come down any lower. So the parabola never comes back down again and gets lower. It only is as low as your vertex. So in this case, my parabola has a minimum. Remember the one I drew before? I think I kind of drew it up here or something. The one I had up here, if I drew it evenly, this parabola would have its vertex. Its vertex, that's the turning point, remember, kind of where it curves like that the most. That vertex would be a maximum in that case. Even if I had a parabola down here, even if it were lower like this is also a maximum because it's the highest point. So first of all, with this max or min feature, you have to decide, is it a max or is it a min? That's your first thing. The one we have is this one is the y-coordinate, we're going to write it's a minimum. I should have two blank lines here. It's a minimum, and the minimum occurs at the y. What's the lowest this parabola gets to? How low does it get to, this parabola? It gets to the lowest value is here. Let me go across. The lowest value is a 1. So the minimum is at y equals 1. That's the minimum value of this parabola. Let me erase some of these markings here. The next feature we want to talk about are the zeros. Whoops, I need a highlighter there. Zeros. And that's the same thing as the x-intercepts. The coordinates of the x-intercepts, now there may not be any. There may be only one, or there can be 2 zeros or x-intercepts. For this graph here, it's never going to cross the x-axis, never. Remember, because I told you, well, this one I put arrows in. It doesn't actually have arrows. Let me erase those arrows. But this will never cross the x-axis. It will have, and those are called zeros because it's down here at the line y equals 0. It will have no zeros. It's never going to cross. I could draw a different one on here, like this one here that I'm drawing. This one would have a 0 when x is 7 and when x is 9, but the one I've drawn doesn't have any. So the answer for this graph, it has no zeros. Z-E-R, you can spell it O-E-S or O-S actually. It has no zeros. Direction of the opening. The one we see here, I'm going to erase my axis of symmetry. Looks like my line shifted there. I can't erase that. The parabola we have here, does it open up or down? So think of it as you can think of it as a smiley face. If we've got a smiley face here, this is a smiley face. This means it's opening up. When you have the curve that has the open part, this is the, across the top here, this is the open part. It's open there. It opens up. This one down here, the open part is here. This is like your sad face. That's a sad face there. Like better eyes and a nose. That's a sad face. That's opening down. So opening up means where is the open part of it? Is the open part of it at the top or at the bottom? And in this case, it's opening up. The open part of the parabola is at the top, so it's opening up. The scale of the above graph is in inches. Answer the following questions. What is the width of the solar stove? So what is the width of the solar stove? If everything you see here is in inches, how wide is it? So I'm going to look from the top, from one side, which is a 3. So from this side all the way to this side, how wide is it? How wide is it from there to there? So that's from a 0 all the way to a 10. So this is 10 inches. That's how wide it is. The width of the solar stove. So I'm going to write 10, but the short form for inches is like quotation marks. And what is the depth of the stove? So let's go and look at our stove again up here. Here's our stove. How deep is it? That means from the vertex, from this part here, up to as high as the side panels go. How deep is it? This is the depth here. So we've got from this, the highest the open part gets to, the wings are at a 3. The lowest we have here is a 1. So how deep is it here? How many units is that? That's 2 inches. So 2 inches is the depth of the stove. Why might an environmental engineer use this shape for an oven? Oh, this and this line here should be below, should be on the next page. So ignore this for now. Why might an environmental engineer use this shape for an oven? So if we were in class for this part, why would an environmental engineer use this shape for an oven? This shape here, I would just get some ideas from you guys. Some common ideas I often hear is it's very open, so it's going to catch a lot of sun. Remember what it is, it's a solar oven. So this would be the solar panel here. It would catch a lot of the sunlight and then it would transfer the heat up. There's a kettle or something on top, and so this element here would get hot. So this shape is good because it captures a lot of sun, and even if the sun is maybe setting, let's say the sun were over here somewhere in the sky. Oops. If the sun were over here somewhere in the sky, right, it's still going to catch, these edges here are still going to catch some of the rays, so that could be one reason. So this last part here, why would an engineer use this shape? So you would just explain why you think. This is kind of an opinion question here. It requires a little bit of thought, but why do you think that they're using the parabola for that? For the following parabolas, fill in the table which follows. Estimate if needed. So first we have a graph, a picture of a parabola. Let me make this a bit bigger. Oh. Can I make it bigger? Yeah. What's the vertex? Remember, the vertex has to be written as a coordinate. So I'm going to put a dot right there. There's the vertex. That vertex, the coordinate is, so when you do the x value first, that's 1, 2, 3. So my x value is a 3. My y value is second, and that's a 1. So my vertex coordinate is 3, 1. Let's do all the vertices at the same time. The next parabola has a vertex. That x value is a -1, and the y value is a -4. So its vertex is -1, -4. What's the vertex of my third graph way up there? So counting up 1, 2, 3, 4, 5. So the that's a y value, and the x value is -1, -2, -3. So putting those together, the x value comes first, -3, and then the y value is a 5. What is the axis of symmetry? And remember, so I put these in here so you remember, the vertex is always a coordinate. The axis of symmetry is always an equation. It's always x equals something. And it's the line, the axis of symmetry, remember, it's the straight line that goes through the vertex. So on all of these, I'm just going to put a dotted line through. This is the axis of symmetry that I'm putting in, and the axis of symmetry always goes through the x value of your vertex. So the axis of symmetry is x equals 3. So you don't even have to look at the graph. I could just give you the vertex, and you would know from the vertex the axis of symmetry is the x value. The x value for the axis. Remember, the word axis has an x in it, so we're looking for the x value, x equals -3. Now we want the zeros, or the x-intercept, and they are to be written as coordinates. The first graph does not cross the x-axis. It has no zeros. The second graph does cross the x-axis here and here. So the first coordinate on the left that I have is -3, 0, and it has another one at 1, 0. Those are these coordinates here that I've circled. How about the third graph? This is a little harder, so I'm going to estimate. I'm going to say that one has an x value of, let's say that's -5.2. 2. I'm going to guess at that x value. This x value, I'm going to guess that one is negative 0.7. So as a coordinate, I've got negative 5.20. That's one of my zeros, or one of my x-intercepts. My other one is negative 0.70. So there's my x-intercepts. The next one, remember, this one's a little tricky because you have to state if it's a maximum or min. We have to do that first, and then we're just going to list the y value. So the first parabola, its vertex is at the bottom. That means its vertex is the minimum. The next parabola, also the vertex is at the bottom, so its vertex is also the minimum. The third one, the vertex is at the top, so its vertex is a maximum. So that's the first part. We decided if it was a max or min. Now we have to find the y value. So it's always the y-axis that we're looking at for the maximum or the minimum. In this case, the minimum the parabola gets to is right there, and that's at a y value of 1. That's where the minimum is. The next one has a minimum value at y equals, where is it? Right here, y equals negative 4. The third parabola has a maximum when my y is equal to 5. The next key characteristic is the y-intercept, and we're going to write it as a coordinate. So as a coordinate, what is the y-intercept? Let me change colors here because everything's dark blue. The y-intercept is right here on my first graph. That looks like about, it's not 6 and it's not 7, so I'm going to write it as a coordinate. Y-intercept means the x value is 0. The y value is about, let's say, let's just go with 6.5. Where's my y-intercept on my second one? So I'm looking for where my graph, my parabola, crosses the y-axis. It crosses it right here at a y value of negative 3. So my y-intercept is 0, negative 3. Third parabola, where does this parabola cross the y-axis? Here's my y-axis. The y-axis crosses it right here. Again, this one's hard to tell. Let's say it's 0 and, oh, let me get it easy. It's close enough to negative 4. I'm going to say negative 4, but you could have said negative 3.5 there. It almost runs along the y-axis. The picture is hard to tell, but it's very pixelated. Direction of the opening. Now for this one, you're either going to say up or down. So where's the open part of the parabola? So the open part of the parabola is here. It's not at the bottom. That's the bottom down there. It's not at the bottom. The open part is at the top. So that means the opening is up. Next parabola, where's the open part? Let me erase a lot of stuff here so that we can see a little better. Where's the open part of the parabola? Is it at the top, the open part, or is it at the bottom? Well, here's the open part right here. And here's the bottom. The vertex is at the bottom, so the opening must be up because it's at the top. We don't say top or bottom. We say opens up or opens down. So this one is opening up. And then the third parabola here, which way, what is the direction of the opening? Meaning the direction of the parabola is opening. So the parabola, the open part is here at the bottom, which means it's opening down. So imagine you had, a cup in your hand. If the open part is at the top, it's opening up. If you turn it over, it's opening down. So this one is opening down. So there are your key features of quadratics, of parabolas. If you made notes here, keep your notes handy when you're doing your homework so you can easily reference all of these. There's a lot of new vocabulary here, but if you do lots of practice, it won't take long before you don't have to look up the words anymore. You know exactly what they mean.